Assalamualaikum warahmatullahi wabarakatuh, and hi everybody. Welcome to PMC 500 Statistical Reasoning in Education. In this video, you're going to learn about independent sample t-test, and I am your lecturer for today. I am Dr. Nur Asniza Ishaq, and welcome in the learning of independent sample t-test. The objective of our lecture today consists of two objectives, where the first one is for you to discuss the understanding of independent sample t-test, and secondly, to analyze and interpret data of independent sample t-test using Spss. So now let us look at what is meant by independent sample t-test. Independent sample t-test is used to compare sample statistics for two set data of two groups. For example, to compare the achievement of two groups of students in one test. So testing difference between two means. Example, you have a mean score for group 1, which is 67 for the score, and the mean score for group 2 is 82. Are these two mean score equal for both group 1 and for group 2? So for knowing that, we need to run an independent t-test. So in this test, we compared these two independent samples. We want to compare whether the mean score of these two groups are statistically significantly different. So when you want to compare means between two groups, the best thing that you would do is to run an independent t-test to compare the two groups of independent samples. However, in order to run an independent sample t-test, like other inferential statistics, you have to fulfill some assumptions. So for independent sample t-test, there are three assumptions that you have to fulfill. The first one, samples are randomly selected from the population and scores of the dependent variables are independent of each other. The second one, the dependent variables for both groups are normally distributed. And the third one, both samples have equal variance. So for the second assumption, which the data must be normally distributed, particularly for dependent variable, you need to run a normality test by using Spss. So in the previous video, I have taught you on how to run a normality test by using Spss. So you go to Analyze, choose Descriptive, click Explore, place test variable in dependent list, place group variable in label factors by, choose Plot, and choose Normality Plot with Test, click Continue, and click OK. So first thing first, you need to look at the normal QQ plot. So in this case, when points from a linear pattern, the distribution is considered as normal, meaning that if the points are near to the linear patterns, your data or your dependent variable data is normally distributed. Another thing that you can do besides testing the normality using graph, you can also test it using the normality test, either use Kolmogorov-Smirnov or the Shapiro-Wilk. So, if your sample is more than 50 samples, you should use Kolmogorov-Smirnov. If your sample is less than 50 samples, you should use the Shapiro-Wilk. What you want to do, or your interpretation for the output of Kolmogorov-Smirnov or Shapiro-Wilk, is that the p-value should be more than 0.05. In this case, for the statistical test score for both class Q and also for class X, it shows that the p-value is more than 0.05. So when p is more than 0.05, the distribution of this data is normal. Right, now let's look at the procedure on running the independent sample t-test after you have fulfilled all the assumptions for running this test. So things that you need to do first is to state the null hypothesis. The first way of writing it is by using symbol. Null hypothesis, mu1. Mu is a symbol used for mean. Mean for group 1 is the same as mean for group 2. And on the other hand, the alternative hypothesis would be mean for group 1 is not the same as mean for group 2. So use this statistic to test the hypothesis. And of course, you need to set the alpha value for the significant level. So usually the alpha value would be 0.05. So now we want to compare between the mean group of group 1 and the mean of group 2. So for the hypothesis, there's another way of writing it instead of using symbol, where you can use words. For null hypothesis, there is no statistically significant difference in the mean scores between the Q and X class in the population. Whereas for the alternative hypothesis, there is a statistically significant difference in the mean scores between Q and X class in the population. So how we can run independent sample t-test using SPSS? First, you need to choose Analyze at the menu bar of the SPSS. Choose Compare Means because independent sample t-test is used to compare means of two groups. Then choose independent sample t-test. Select the test variables. Select your group. Define group, example 1 and 2. And then choose options and choose 95% confidence interval. And after that, you click Continue and press OK. So this would be the SPSS output of the independent sample t-test after you have run using SPSS. So first, you will see a table of group statistics where it shows the descriptive statistics of your data, your variables, the populations or the total number of the sample for each group, the mean, the standard deviation, and also the standard error of mean. The second output or second table that you will see is the independent sample t-test, where first it consists the Levine test for equality of variances, and secondly it consists of t-test for equality of means. So let's look at the first test that come out from the output of the SPSS, which is the Levine test for equality of variances. So it's a test whether the variances from two samples are different. Since the third assumption of the t-test is that you should have an equal variances for your samples. So if the p-value is less than 0.05, the two variances are probably different. But if the p-value is greater than 0.05, the assumptions of equal variances is met. So which one do we want? P-value less than 0.05 or p-value is greater than 0.05? So the answer for that is the p-value should be more than 0.05 as it indicates that the assumptions of equal variances is met. So this is the output of the Levine test for equality of variances. You should look at the p-value, and the p-value here in this example is 0.919. 0.919 shows that the p-value is greater than 0.05. Thus, not significant. The two groups have equal variance, so assumptions is met. So what is F? F is a value as test statistics. But in Levine test, we're more concerned on looking at the p-value where it should be more than 0.05. So if your p-value is more than 0.05, indicating that for Levine test, the equal variances is assumed, you should continue reading the first row, which is equal variance assumed. But if your p-value for the Levine test is less than 0.05, you should read the second row, which is equal variances not assumed. In this case, the p-value is 0.919, which is greater than 0.05. You should read the first row because equal variances is assumed. So now, let's look at the t-test for equality of means. Again, you should look at the p-value. p-value for t-test indicates that the p-value is 0.559, which is greater than 0.05. So if it's greater than 0.05, meaning that you reject the null hypothesis. If the p-value is less than 0.05, your conclusion is that you reject the null hypothesis. If it's more than 0.05, meaning that you fail to reject the null hypothesis. So what is T? T is t-statistic for the hypothesis test. What is DF? DF is degree of freedoms. Significance is to look at the p-value. You have the mean difference, standard error difference, and 95% confidence interval of difference. So usually in interpreting the t-test, you should look at the t-value or the t-statistics, the DF, as well as the p-value. So now the p-value, like I said, is 0.559. So when t equal to 59, p-value is 5.6 because we looking at 2 decimal places, and the DF is 38. So 38 is the value of 38. You got it from the value of DF, from the DF. So t equal to 0.59, DF is 38, p equal to 0.56, where p is more than 0.05, thus fail to reject the null hypothesis. Thus, lengths of hair for males and females are not significantly different for this example. So now let's look at more examples. Right? We have 2 groups, Group A and Group B. We want to look at the distance for Group A and Group B. So first of all, you need to state the null and alternative hypothesis. So the null hypothesis, there is no statistically significant difference in walking distance between Group A and Group B in the population. Or you can also write it in a formula or in a symbol form. Whereas the alternative hypothesis is there is a statistically significant difference in walking distance between Group A and Group B in the population. So first, you need to look at Levine test for equality of variances. If the p-value is more than 0.05, it shows that the population have equal variance. If it's less than 0.05, the population do not have equal variance. So since p is 0.85, which is more than 0.05, we say that both samples have equal variances and the assumption is met. Now we need to look at t-test for equality of mean. So you need to read the first row, which is equal variances assumed, and go to significant to tail, then looking at the p-value. So what is the decision of this test? So from the t-test, t is equal to 0.43, df is 2.42, and the p-value is 0.67. So p is more than 0.05, thus we fail to reject the null hypothesis. There is no statistically significant difference in walking distance between Group A and Group B in the population. Okay, this is another example with vehicle between the European car and the Japanese car. So this would be the null hypothesis. There is no statistical significant difference in vehicle weight between European and Japanese. And for the alternative hypothesis, there is a statistically significant difference in vehicle weight between European and Japanese. So look at the Levine test first. In this case, the p-value is less than 0.05. So what does it mean? Thus, both samples do not have equal variance and the assumption is not met because the p-value should be more than 0.05 to get equal variance here. So you will need to read the second row, not the first row. So what is your decision? When reading the second row, t is equal to 3.15, df is 150, and the p-value is less than 0.05. Thus, we reject the null hypothesis and saying that there is a statistical significant difference in vehicle weight between European and Japanese. So hope that you understand t-test and the concept of t-test especially. Thank you very much and have a wonderful day. Bye.